Hello everyone, welcome to this video. In this video, we'll be solving this question which states that if you are given a plus bx divided by a minus bx is equal to b plus cx divided by b minus cx, that is equals to c plus dx divided by c minus dx, where x is not equal to 0, then you have to show that a, b, c and d, they are in GP. So what you need to show? You need to show that their ratio b upon a is equals to c upon b is equals to d upon c. Right, so let's mark this as equation 1. What you are given here, let's mark this as equation 1. So here, first of all, you take the first two equalities, first two term of the equality, so you will be taking these terms. Now you can apply componendo and dividendo, C and D. Now what is this componendo and dividendo? You should understand this thing here, that if you have some P upon Q is equals to R upon S, so componendo and dividendo, what you do, you add up the numerator with the denominator, so P plus Q, and then divide it by subtract both the numerator and denominator and write it in the denominator. This is equals to, here also on the right hand side also you do the same. You add the denominator and the numerator, write it in the numerator, and then you subtract the numerator and denominator and write it in the denominator. This is what you do in the componendo and dividendo. So we are adding these two first of all here, and then we are subtracting them here. Similarly, we are adding these two together here, and then we are subtracting them together here. Right, so you see this bx and bx cancels here, and this a and this a cancels here. Similarly here, cx and cx cancels here, and b cancels here. So you are left with 2 times of a here and 2 times of bx here, right, and here 2 times of b and divided by 2 times of cx. This is what you have. So you see 2 and 2 and 2 and 2 gets cancelled. So what you can do, you can shift up the term. So you can take c to that side, right, and you can bring this a to this side, so that you would have a upon this term b upon a is equals to cx upon bx. So this x and x also gets cancelled, and you have both of the both these ratios equal to each other. So let's mark this as equation number 2. Now what we can do, we can take up this second part here of this equality from equation 1. Let's consider the second part. When you consider the second part, we can apply the componendo and dividendo portion. So what you can do, you can add up these two numbers, quantities here, and subtract them together here, and then you can add them together here, right, and then subtract them together here, so that in this case it would be the cx gets cancelled, b and b gets cancelled, dx and dx gets cancelled, c and c gets cancelled. So you are left with 2 times of b divided by 2 times of cx, here 2 times of c divided by 2 times of dx. So you see this 2 and 2 gets cancelled. You can shift this b to this side and dx to this side, so that you would have this term c upon b is equals to d upon x, dx upon cx. So this x and x also gets cancelled, so you have this term. Let's mark this as equation 3. Now from equation 2 and from equation 3, you have b upon a equals to c upon b, where c upon b is further equal to d upon c. So therefore you have these three ratios equals to each other. Hence from here you can very clearly say numbers a, b, c and d, they are in GP, and this is what we wanted to prove here in this question. So I hope you understood this question well. That is it for this video. Thank you for watching.